Variables represent unknown quantities such as numbers. These will be written as letters in the mathematics, but they really just represent some number, and we're going to treat them like a number. You want to name a variable when you're going to be using them in a problem. Name them something that relates to what they represent. If you can't, come up with a good choice of it, then X is always a good choice. X is the classic choice for a general variable. Now, if I had some equation like this, x equals 3 times 4, well, then 3 times 4 is 12. That means x is just 12. In this case, the unknown variable is actually the known quantity 12. If x equals 2.5 times 8, 2.5 times 8 is 20. So the unknown is now 20 in this case. 0.25 times 50 is 6. So in this case, x would be equal to 6. We like to study variables because they allow us to solve general solutions. And to solve for a variable, the goal is to get the variable by itself. We can always check to make sure we found the correct solution for the unknown quantity, the variable, whatever variable you're using. We can plug it back into the original equation that we had and then check to make sure. Now, not every time do you have to do a process of solving for a variable. You can actually just guess, right? Here we have what number times 2 is 8. So what times 2 is 8? Well, that is just 4. X equals 4. The way we would actually solve this is by getting the variable by itself. Here I have 2 times the variable. I can get rid of the multiplication by doing the inverse operation. The inverse of multiplication, or what undoes multiplication, is division. So I divide by the number that's multiplying the variable. That gives me 8 divided by 2 is 4. So I found 4, that's correct. 4 times 2 does give me 8. What number times 6 gives you 18? Well, that has to be 3. 3 times 6 is 18. Also, I can divide by 6. 18 divided by 6 is 3. So yes, that checks out. 5 times what number is 50? That means 5 times 10 is 50. Otherwise, I can just divide by 5. 50 divided by 5 is 10. So for in general, if you can't solve it by just guessing it, then doing the division will solve the problem here. Here we're going to solve for a. I'm going to divide by 1/4. Divide by 1/4. I'm dividing by a fraction. That's the same thing as multiplying by the reciprocal. I'm going to multiply by the reciprocal of 1/4, which is going to be 4/1. So 9/1 times 4/1, it's going to be 36/1, which is just 36. 1/4 times 36. The 4 and the 36 can cancel, right? The 4 and the 36 cancel to give me 9. 1 times 9 is 9. 1 times 1 is 1. We get 9/1 equals 9. That's a true statement. I was just checking my work there. Okay, for this one, we can divide by 5. Divide by 5. B equals, you can either write it as 12/5, just leave it as a fraction, or you can do the division on a calculator and get the decimal number. This would be 2.4. Of course, I can check my work by taking 5 times B. 5 times B is now 12/5. This is 5/1. 5s can reduce. We get 1 times 12 is 12. 1 times 1 is 1. 12/1 does equal 12. I get a true statement, and that means that my answer is correct. Finally, 6 divided by, or divided by 6 on both sides. That's going to give me 11/6. Going to give me 1.8333, and just repeats. This one's probably best to leave it as a fraction because that's a exact solution. And of course, 6 times 11/6 equals 11. 6/1. Those reduce. We get 11/1 equals 11. That is a true statement. So I know I've done it correctly. Now, if 12 markers cost $4, how many pens can we buy with $11? So we can solve this by finding the unit rate. If 12 markers cost $4, then 12 markers per $4 is going to be 3 markers for $1, or 3 markers per dollar, right? It's for each dollar you can buy 3 markers. If we have $11, then all we have to do is take 11 times the unit rate, which is three markers per dollar. Cancel the dollar amounts. We get 11 times 3. 1 times 1 is 1. 11 times 3 is 33 markers. Now, we don't have to find this unit rate. Sometimes it's not necessarily obvious, or it's not a nice number to work with. We can actually skip finding the unit rate by using a proportion. And then we can solve the proportion by cross multiplication. When we have a proportion that we're going to use to solve it for an unknown quantity, we're going to use a variable in that unknown quantity, and we're going to use a method called cross multiplication to solve the proportion. It's quite simple. All you got to do is set up the proportion, and then we're going to go across the equal sign. So 12 times 11 and 4 times m. Well, here we have 132 equals 4m, and we were just solving these variables. We can solve this by dividing by 4. 132 over 4, that gives you 33. Okay, so let's go ahead and solve some general proportions. Cross multiply. I'm going to go 3 times 4. X times 2. I can write it either as x times 2 or 2x. It's the same thing. I get 12 equals x times 2. And then I'm going to divide by 2. That gives me x equals 6. So here what I've found is that if I replace this with 3 over 6 equals 2 over 4, x is just 6, so I just replace it there. This is a true proportion, and I can actually check this easily because 3 times 2 is 6, and 2 times 2 is 4. So the proportion is working out on going from top to bottom. You can also go across. In this case, is not quite as obvious. I mean, it's just going to be 1.5. So 2 times 1.5 is 3, and 4 times 1.5 is 6. You can also do that method instead of solving the cross multiplication. But the cross multiplication will always work. Here, I can see that 7 times 3 is 21, which means I know the solution is going to be 3 times 3 is 9. So I know this should be 9, but let's just prove that true by using cross multiplication. So going across, I get 7 times t, or 7t, and 3 times 21 is going to be 63. If I divide by 7, I get t equal to 63 over 7, which is 9. And that does check out. Okay, in this case, I can see that 4 times 3 is 12. So 2.5 times 3 is going to be 7.5. So I expect my solution to be 7.5. Let's prove that. 2.5 times 12 is going to be 2.5 times. It's going to be 12, 12, and 6. So 30. And y times 4, you gotta write it as y times 4 or 4y, kind of like how I wrote 7t here. Now I can just divide by 4, and that's going to give me 30 over 4 is the same thing as 15 over 2, or 7.5. And that does indeed check out. Okay, this one I can see that 6 times 2 is 12. So in other words, I need to multiply this one by 2. 2 times a quarter, this is the same thing as 2 over 1 times 1/4. I can reduce those, and I get 1/2 as the solution. So I expect 1/2 to be my answer, but let's do the cross multiplication to check. 1/4 times 12, or 12 over 1, and then 6 times x, 6x. I can reduce this to 3. That gives me just 3 on this side. Divide by 6. and I get x equal to 3 over 6, which is the same thing, dividing top and bottom by 3. I get 1/2, and that checks out perfectly. Okay, for this one, I'm not seeing a easy way to check the solution here, like I did in the previous ones. So I'm just going to do cross multiplication. 1.5 times 6 is 9. And 3/5 times r. Divide by 3/5. Those cancel. And that gives me r equal to 9 divided by 3/5 is going to be multiplied by the reciprocal. 9 over 1 times 5 over 3. And I can cross cancel. 3 times 5 is 15. R equals 15. That seems reasonable from this solution. 3/5 is the same thing as 0.6. So what we could do is we could actually move the decimal point over 1. That gives me 15 over 6, and that's exactly what I had just solved for. So everything does check out in that case. Okay, this one may not seem like a proportion, but we can just do 5 over 1, and now it is. So let's cross multiply. It's going to give me 2.4 times 1, and 5 times c, or c times 5. It doesn't matter which way you do it. Divide by 5, and I get c equal to 2.4 over 5. Make the decimal point a little bit clearer here. I get 0.48. So if I were to check that, I could do 2.4 over 0.48. 1, 2 spaces, 1, 2 spaces. It's 240 over 48. I can reduce that down by 4. It's going to be 60 over 12. And I can divide top and bottom by 12. That gives me 5 over 1, and that is 5 over 1 here. So that all checks out.